Okay, this is a rooftop rainwater harvesting system example. And in this scenario, we have a family of 4 who wants to capture rainfall falling on their asphalt roof, and the roof has a runoff coefficient of 0.85. So you are to design the rainwater harvesting system using the month with the highest precipitation, which is a good way to go, designed for the highest expected rainfall. And in this case, it's February, which has an average rainfall of 40 millimeters per month. For a roof area of 20 meters by 10 meters, assuming that the family of 4 will use the harvested water mainly for flushing in their home, and the demand then for the water is going to be from a rate of 25 liters used for flushing per person per day. Also assume there's no water captured from the previous month and that the first flush volume is 100 liters. Provide the tank volume and sketch of the rainwater harvesting system. Okay, so it's always a good idea to take note of what our knowns are in our example in the problem statement. So we know the runoff coefficient for the roof is 0.85. We know it's a roof that's 200 meters squared, and that there was no previous volume to account for from the month before. And the precip that falls that month is 40 millimeters or 0.04 meters. The demand that's going to be needed for the toilet flushing is for 4 people, and they're flushing 25 liters per day, and it's the month of February, so it's 28 days. Okay, so persons cancel out, days cancel out, so we get that the demand is 2,800 liters per month, or 2.8 meters cubed. Remember, there's 1,000 liters in a cubic meter. Okay, and that volume of the first flush, that dirty water that we want to get rid of, that's 100 liters or 0.1 cubic meter. Again, 1,000 liters in a meter cubed. All right, so equations that are important that were given in our notes are that the volume of the tank is the volume previously to account for from the month before, plus the runoff. Okay, so these are kind of the inputs, minus the outputs, the demand for toilet flushing in this case, minus the first flush volume. So our volume of runoff is given by the second equation here, which is the precipitation in meters, the area in meters squared, times the runoff coefficient. Okay, so the first thing we need to do is calculate the volume of runoff, and that's just going to be the precip, 0.04 meters per month, times 200 meters square roof, times 0.85, or 6.8 meters cubed. All right, so that's that term. Then we can substitute into our main equation, which is the tank equation, tank volume, and we know that the previous volume was 0. The runoff we just calculated is 6.8 meters cubed. The demand we calculated as 2.8 meters cubed, and the volume of the first flush is 0.1 cubic meter, and we add those all together and we get 3.9 meter cubed tank, which is the same as 3,900 liters, right? And so we might find a tank that's maybe a 4,000 liter tank. We're not going to find one that's exactly 3,900, right? So we'll find maybe a 4,000 to 5,000 liter tank, and that's okay if it's a little bit bigger. These are rough calculations to just kind of estimate how much water we're going to need. How much volume we're going to need for our tank. All right, so in our schematic here that we're drawing, we want to show the gutters. We want to show the tank. Yes, the tank, the 4,000, 5,000 liter tank, and maybe some sort of a device here that's 100 liter volume little device on the side, that when that fills up, then the water is diverted and the clean water ends up in the tank.